Okay, today's lesson is going to be over Pythagorean theorem with real-world problems. All right, so right here, hopefully you see that we have a right triangle. Oops, let me change colors. All right, so right here we have a right triangle. And remember, Pythagorean theorem is a squared plus b squared equals c squared. And hopefully remember that a and b are the legs of our triangle. C is our hypotenuse. Okay? So, Pythagorean theorem is a really simple way that you can calculate some real-world problems. Like, for example, this, finding how they measure TVs, is Pythagorean theorem, because they actually measure by the diagonal of the TV. So again, remember the hypotenuse is always across from your right angle. So here's your C. And your two sides that create the right angle, so here and here, are your legs. Okay, so here's A, and then this side, here's B. All right, so just real quick again, to find hypotenuse, it's the traditional A squared plus B squared equals C squared. And then to find a leg, that means we know our C squared, our hypotenuse, and we're going to subtract one of our legs with that to find our third leg. Remember, this is the one that we are trying to find. All right, so let's look at some of these examples. So, here's an example of the pitch of a roof. Okay, so you see our right triangle, hopefully, which is right here. They have it drawn out for you already in this diagram. Okay, and they even have it labeled rise and run, just like we learned to find slope. So let's say that we know the run of our roof is 36 inches, 3 feet. We also know that by code, we kind of know the diagonal then, and so the diagonal would be 40 inches. But if we know this information, how tall do I need to make my roof? Okay, what's my rise? How far up do I need to go? All right, so let's look at what we know. This is across from my right angle, so this is my C, which means this is my leg. I'm trying to look for my other leg, so I'm going to go ahead and label that B. So since I know my hypotenuse, we're going to go back to C squared minus A squared equals B squared. My C squared my C is 40, so 40 squared. My A is 36, so 36 squared equals B squared. Okay, just plug these into the calculator if you need to. So 40 squared is going to give you 1,600. We're going to subtract 36 squared, which gives us 1,296. And again, we're still looking for that third side. Okay, one of our legs. So let's do some math, and I want this round to the nearest tenth. Okay, so I get 1,600 minus 1,296. So I get 304. Gives me my leg. So again, inverse operation. So remember, and I said this on another video, but in case you didn't watch that one, inverse operations, adding and subtracting. Okay, multiplying and dividing. So squaring and square rooting are inverse operations. So to get rid of something that's squared, you take the square root of it. Okay, so that leaves me with B over here. So I take the square root of 304, and if you take the square root and if you round to the nearest tenth, we're going to get 17.4 inches. So we have to have our rise at 17.4 inches. Okay. All right. Let's look at another example. This deals with a ladder leaning against a house. So what we need to look at is first, where is our triangle? So if you look right here, we have made a right triangle. Okay, opposite my right angle is going to be my C. The two sides that form my right angle are going to be my A and my B. All right, so what if we have this information? We know we have a ladder that is 13 feet tall. And we're wanting it to reach 12 feet on the house. So what is the safe distance the ladder needs to be? Oops. From the house. Okay, so let's plug in the information we know. If we know the ladder is 13 feet tall, so this ladder is 13 feet, and we want it 12 feet high on the house. So how far a safe distance the ladder needs to be from the house? So the ladder needs to be from the house. Here's what we're searching for. So this is what we're trying to find. Remember, that's what's going to be isolated on the equal sign. So now let's fill in everything else. C squared minus A squared. Okay, the value of my C is 13, so 13 squared. Value of my A is 12, so 12 squared equals B squared. Well, 13 times 13, 169, minus 12 times 12, 144, is equal to B squared. 169 minus 144, gives me 25. I don't know what I was thinking there. 25 equals B squared. Inverse operation. Cancels, cancels. Inverse. So over here I'm isolated in my B. Square root of 25 is 5. So we would need to be 5 feet. Let me start that over. 5 feet from the house. All right, I'm going to just, if you can't remember the subtraction, and you come over here and you do the traditional A squared plus B squared equals C squared, you're going to get the right answer still. So we know our value of A is 12, so 12 squared. We don't know B, and then we know that C is 13 squared. So it's the same process, it's just one extra step. So 12 squared, again, we're going to get 144. Bring down our B squared equals 13 squared, which is 169. So inverse operation. Okay, subtract our 144 on both sides. So drop our B squared down, equals 25. So see, you still come up with this, even if you do the traditional A squared plus B squared equals C squared. There's nothing magical with this. It's just one less operation, meaning hopefully one less chance to make a mathematical error. Because then we're going to do inverse again. Inverse operation. So we're left with B equals square root of 25 is 5. So there's not one way better than the other. It's just how do you prefer it. If you can always remember this and that's your go-to, do it. All right. Let's look at another example. Now we're looking at a wheelchair ramp. And by code, I believe of a wheelchair ramp, every 1 inch that your wheelchair ramp height, for every 1 inch tall it is, it has to be 1 foot out. So here's our triangle. Here's my right angle, which means this is my hypotenuse, so the other two are left with my legs. I always like to go ahead and label everything. So what if I say that this wheelchair ramp is 1.5 feet tall? Well, if we know it's 1 foot 5, okay, remember, and I just said it has to be for every 1 inch tall, it's 1 foot in length. Okay, So if I tell you that it's 1.5 feet tall, I like to go ahead and just work in inches. So 1.5 feet tall, if we convert that, that's going to be 18 inches. So if I know that this is 18 inches, that means that this has to be 18 feet. But let's convert that to inches. So 18 feet, so 18 times 12, we got 216 inches. All right, so I know that if I have a ramp that's 18 inches tall, it has to be 216 inches long. Well, now we're trying to find C. So what's the diagonal of this? All right, so I have 18 squared plus 216 squared, because remember we want inches and inches, equals C squared. So 18 squared is 324 plus 216 squared is 46,656. And that's going to give me my diagonal squared. Okay, so let's add this together, and we're going to get 46,980 equals C squared. Again, inverse operation. So this is going to cancel and get my C isolated. The square root, again, round to the nearest tenth. The square root of 46,980 is going to give us 216.7 inches. Okay. So again, this is another way that it is used in the real world to figure out by code what the dimensions have to be. If you know a certain, you know you can only go up so high, then you can figure out the length. Okay. Now let's look at a couple where it just gives you the descriptions, and you have to draw yourself a picture. So this first one, a certain television is advertised as 37 inch TV. That's the diagonal length. So remember I was telling you earlier, TVs, here's my TV. When you say you're going to go buy a 32-inch TV, then what you're measuring is this right here. This would be 32 inches. So for this one, and it tells us the diagonal is 37 inches. If the width of the TV is 12 inches, then how tall is the TV? Okay, we're looking for the height of the TV. So let's look at what information we have. There's my right angle. So here's my C. We're going to be looking for this side, which is my A. So I have B left over to search for, or that I know. Okay, so if I'm looking for a leg, that's what I'm trying to find. So I want that isolated. So I have C squared minus B squared equals A squared. My C squared, or my C, is 37. We're going to square that minus my B, which is 12. We're going to square that as A squared. Well, 37 squared is 1,369 minus 12 squared, which is 144, which will be A squared. Some simple math here. Let's do 1369 minus 144, which is going to give me 1,225 equals A. Oops, I forgot my squared here. And then we are going to square root. Inverse operation, square root. So I'm left with A. Square root of 1,225 is 35. So 35 inches. Okay, so draw a picture. Draw a picture so you know exactly what sides you have. All right, one last example. All right, and I really like these. You start driving north for 9 miles, turn right, and drive east for another 40 miles. At the end of driving, what is your straight line distance from your starting point? So you need to give yourself a starting point. All right, so here's where I'm starting from. and I went north 9 miles. North, 9 miles. Then I turned right. So now I'm going to go this way. I turn right, and I drive east for another 40 miles. So I drove east for 40 miles. What is your distance, your straight line distance from your starting point? So what is my straight line distance? And I know it's going to be C, because here's my right angle. There's my hypotenuse, which means I have A and B. Okay? So a squared plus b squared equals c squared. My a is 9, so square that. My b is 40, square that. And I'm going to search for my c squared. Since I'm finding this, I'm going to isolate that on my equals. Okay, so 9 squared, 81. 40 squared, 1600, equals c squared. Let's add this together, and we get 1,681 equals c squared. All right, inverse operation cancels. Inverse operation, I'm left with my c. Square root of 1,681 is 41. So I am 41 miles. Okay, I hope this lesson helped you all out. If you have any questions, please let me know.